Okay, I wanted to talk with you about a couple of problems here for this section. First one I have up here is to use transformations to graph f of x equals 5 to the x to graph h of x, which we see here is 5 to the x plus 5 power minus 3, and then put in some other information along the way. So I wanted to give you an example of that here, the way you enter all that in on the computer. Well, I've got this function here written down on the side here, and what we want to do is, first of all, it noted there that this h of x graph is the graph of f of x equals 5 to the x, but transformed. And so, as we know from previous discussion there, we know that this f of x equals 5 to the x, that's our kind of a hockey stick shape. We know that if, well, just a couple of values here, x and y, if x is 0, then y would be 1. If x is 1, y would be 5. Just plugging in those values, x is 2, y would be 25, 5 squared. And so we do get the basic shape here of 0, 1, 1, say there's 5, and then 2 is way up at 25, 15, 20, 25, okay. So it goes up this way. And then, as we know, this one comes around and we have a horizontal asymptote of y equals 0 for just that base function. Okay. All right, so looking back here at h of x, we notice that the shift that goes on here, the two parts of the shift that goes on, we know that the minus 3 here, it's located on the outside, so that would affect it by shifting the graph down 3. And so that takes everything of this 5 to the x graph, and we'll move everything down 3 units. And then the plus 5 being there on the inside, well, that's going to shift it right or left, and of course plus there for the horizontal shift, that would mean it goes to the left, 5. And so all these points that we have for the 5 to the x, those are going to be shifted down 3 and then to the left 5. Now, in particular, what that means is so I want to take this down 3 and to the left 5 to get the graph here of h of x equals 5 to the x plus 5 minus 3. Okay? All right. So if I do that, here is what happens. These points, down 3, to the left 5. So if I go down 3 on this point, which is at 1, on the y-axis, so if I go down 3 with it, 1, 2, 3, let's say that's negative 5 right there. And then to the left 5, 1, 2, 3, 4, 5. Okay, that's going to put me right about there. And the same thing for all those other points. Down 3 and to the left 5. Just kind of get a pretty good idea of what is happening here. Now, in particular, since I've shifted everything down 3, this horizontal asymptote is also shifted down 3, so it no longer is there at 0, but it would be down 3, and so the horizontal asymptote now is at down 3 from 0. That would be negative 3, wouldn't it? All right, so at negative 3, wherever that is, let's call it right there, we're going to have a horizontal asymptote. So this is our basic graph here, and I think we should be able to graph it over here now in our homework problem. All right, so let's see. All right, so of course, what we want to do, we know we got the hockey stick for the exponential, so I'm going to choose that form, and then just click on it, and it'll put one on there for me. All right, and so what it wants you to do here is tell it about the vertical stretching or horizontal stretching, which we don't have either one of those, or the vertical shift, horizontal shift, which we do have that. We already said that our vertical shift here, up or down shift, we said we've got a downshift of 3, so that'd be a negative 3 vertical shift. So we're going to slide that little slider over there, if we can, to negative 3. All right, and then left 5 is our horizontal shift right there. And so our horizontal shift here is left 5, which would be negative 5. Right would be positive 5. Right 5 would be positive 5. So I want to slide that to, I think I did negative 4 there, so I want to slide it to be a negative 5. Right there. Okay. All right. Now also on this too, it wants me to graph the equation, graph the function, and graph the asymptote. And so we've also got to graph our new asymptote here, which we said was down 3, so it'll be at negative 3. And so that's just a regular old line. Let me get it where we can see this a little better. All right, and so instead of the hockey stick, I want the line shape now. And I want that to be a dotted line, so I click the dotted line. And we're going to put it here at negative 3. And all you have to do is just put a couple of points on that line. I did 0, negative 3, and you can just come right over to 1, negative 3. And that'll put in the horizontal asymptote right there. So it wants those two things. It wants the graph and that horizontal asymptote. All right? So once you get those two things in, check your answer. Okay. Good job. And then it wants you to verify here, what is the equation of the horizontal asymptote? Well, that would be negative 3. Get where I can type in here. Okay, check my answer. Okay. And then it wants the domain, the x values. X values can be anything. So it would be negative infinity. Negative infinity. Comma, positive infinity. All right, and then of course our range, the y values, well, the y values are just negative 3 to positive infinity. that one. Okay. All right. Now I wanted to show you one more on this real quick here, and that is how you do the the ones where we have the decreasing hockey stick. I want to sketch the graph of f of x equals 7 to the negative x, and like we said, that one is that one's just going to be a whole different graph. It's the it is the decreasing hockey stick, like this. For f of x equals 7 to the minus x. We know we've got the decreasing hockey stick. Flipped it over there. And but I want to show you how you have to do it on this one. If we go to the graph here on this, so yeah, again we've got the hockey stick shape, and when you click on it, yeah, that's going to put it as the increasing one. And so we need to flip that up around. Well, the way you do it over here, another way you can look at it is what we've done is we've reflected. If you have f of x equals 7 to the x, we've reflected 7 to the x is that shape right there. And so what we've done is we reflected that in the x-axis, in the y-axis. So we reflected, flipped it around the y-axis there, and so that's how we enter that in, or get that entered in over here. We have a y-axis reflection of our 7 to the x. So 7 to the minus x, you put that in as a y-axis reflection, and about it. Okay? All right.